Gravity waves and India. India has been in the news recently in the scientific community of the world because of possibility of establishing what is called a LIGO laboratory. Now, what is LIGO? LIGO is the Laser Interferometer Gravitational Wave Observatory. It is a large-scale physics experiment and observatory to detect gravitational waves. It is a national facility for gravitational wave research, and it provides opportunities for the broader scientific community to participate in detector development, observation, and also data analysis. In physics, gravitational waves are ripples in the curvature of space-time, and they propagate as waves and they travel outward from the source. Now, Albert Einstein long back predicted the gravitational waves transport energy as gravitational radiation. The existence of gravitational waves is a possible consequence of the general relativity theory. Gravitational waves cannot exist in the Newtonian theory of gravitation because it postulates that the physical interactions propagate at infinite speed. But in Einstein's theory of general relativity, the gravity is related as a phenomena and it results from the curvature of space-time. This curvature is caused by the presence of mass body. Generally, the more the mass that is contained with a given volume of space, the greater is the curvature of the space-time will be the boundary of this volume. As objects with mass move around in space-time, the curvature changes to reflect the changed locations of those objects. In certain circumstances, accelerating objects generate changes in this curvature. They propagate outwards at a speed of light in a wave-like manner, and these propagating phenomena are known as gravitational waves. Now, before the direct detection of gravitational waves, there was indirect evidence for their existence. Potential sources of detectable gravitational waves also include binary star systems. Now, in February 2016, the LIGO scientific collaboration and Virgo collaboration teams across the world announced that they had directly detected gravitational waves, and it was from a pair of black holes merging. For this, they used advanced LIGO detectors. Though the scientists abroad claimed they have detected the gravitational waves, India too has played very significant role in this gravitational waves matter. Along with this discovery, LIGO India is proposed collaborative project between the LIGO laboratory and the Indian Initiative in Gravitational Wave Observations, that is INDIGO, and it would create a world-class gravitational wave detector in India. The LIGO laboratory is in collaboration with the US, UK, Germany, and Australia, and they have offered to provide all the designs and the hardware for one of the 3 planned advanced LIGO detectors, and that would be installed and commissioned and operated by an Indian team of scientists, and that facility would be built in India. Now, LIGO's objective is to expand worldwide activities in gravitational wave detections. This way, it wants to produce an effective global network. Now, as said before, India has played a very vital role in the discovery of gravitational waves. The discovery of gravitational waves has shaken the world when it was announced in February 2016, alright. But one of the people at the heart of this discovery was a 77-year-old Bangalore-based professor by name Professor Vishweshwara, and he is not only among the first in India to study black holes, and he has also made a very important calculations that was used in this discovery. Professor Vishweshwara was one of the first to analyze the structure of black holes. He proved the stability of non-rotating black holes. Further, he discovered the quasi-normal mode of black holes. These modes of black hole vibrations are one of the main targets of observation by the modern gravitational wave detectors. Professor Vishweshwara also has made significant contributions to other areas of general relativity, such as exact solutions of Einstein's field of equations, gravitational collapse, etc. Professor Vishweshwara obtained his PhD from the University of Maryland, and he subsequently served on the faculties of New York University, Boston University, and also University of Pittsburgh. After his return to hometown of Bangalore, he was senior professor at the Raman Research Institute and the Indian Institute of Astrophysics. Professor Vishweshwara was also the founder director of the famous planetarium in Bangalore, and he has written the scripts of several planetarium programs and directed them. These have proved to be exceedingly popular because of the simple and attractive manner in which the difficult concepts have been presented. Besides this, Professor Vishweshwara also has produced 2 short science films. Now, essays in honor of Professor Vishweshwara, that is, black holes, gravitational radiation, and the universities have been published, which proves his original contribution to the gravitational wave theories. Now, these studies indicate that the detector in India would provide a significant improvements in the research and other related applications. A location in India was discussed at the Joint Commission meeting between India and the US in June 2012. The project has been presented to the Department of Atomic Energy and the Department of Science and Technology for approval and funding. The final approval, of course, is yet to come. The proposal of establishing such a setup on the part of the India is estimated to cost around 1,200 crore rupees. Now this project, Indigo, will be a replica of the 2 LIGO detectors, and many of its components have already been built and they are ready to be shipped from the United States. The Deccan Plateau, that is the South India, has been found to be the best suited for locating this Indigo project. It is noted that the Indian scientists have over 30 years of period contributed, as said before, substantially to the gravitational wave